Welcome, everybody.
Hello. Hello, everybody. The body is of hello. Yeah, that's just the bodies of hello. That's all it is.
Wow,
Nothing else.
really genius words here from Leo.
How's everyone doing today?
I'm tired.
Oh, Logan. You're tired, but the things that I'm doing right now are quite ridiculous. Leo's beard is majestic. I think Logan's is better. Logan's is like way better.
This is good, man. It pulls out of your face a little bit more. I think.
Mine?
Yeah,
I think it's cause
it just needs to be trimmed.
yeah, I think it's because it needs to be trimmed.
I
I
feel
think,
that
but
one.
I,
I feel
but I
that
feel
one.
like I don't think I'm gonna do it. I think I'm gonna let it grow and see how far I can go. Also, I learned a little trick where it's like if you don't shave part of the underside, it looks like it's much thicker.
Yeah, but like
I didn't know
if you
that.
do shave the underside, then it looks normal.
No, but like,
Bro,
I
you don't want to
guess
start getting a neck beard.
no, but I don't have a neck beard. But you see like how the beard here kind of covers it. It's because I have it under here and it looks thicker than it should.
All right, sure,
All
sure,
right,
sure, 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 sure. All right,
all right.
what are we going over this week?
Let what I'm hoping it's trees because we did graphs last week. So
We
we
did
should be
graphs
doing
and
trees.
trees last week, so
Well, we did both, yes. But
we're
we're
probably gonna end up going over both again, if I had to
if you
guess.
guys still have more
Okay, hold
questions
on.
about
I gotta
both.
close because the sun is like, while the sun isn't being super sunny, there's like a ton of clouds and it's diffusing the light through the sun, and it's way too bright.
Got you.
Okay, I can see now, which is kind of sick. All right, what are we going over?
No questions in the chat about what we're going to go over? Come on, guys. I know we have questions
Supposedly,
because I know those trees don't make sense.
or they do, in
Or they
which
do.
impressive.
Because I know they don't make sense right now to me. I'll tell you that
Interview
much.
stuff.
Interview stuff. I guess
I mean, that's just
honestly, I have no problem going over interview stuff only because if I remember correctly, it's just whatever Jesse teaches and
yeah.
it's very
It's
easy.
just LO3, LO4. So
Yeah.
it's graphs, linked lists, and
Well,
trees.
here, you know
It's
what?
all of it.
You know, what's a good thing, Logan.
Yes.
Um, I wish I could share my screen, but go to the CSE116.com website and just go to LO4 in the syllabus. That's all I would. That's that's what I want you to do, and so just yeah, and then just share that really quickly. So, do you see where it says explain? Describe the structure of linked list trees, graphs, and the implications of these structures, including applications of each. That's your interview.
It's literally the entirety of it.
That's your interview.
That's all the information we will give you for your interview. You have to know what the structure of a linked list is, what the structure of a tree is, what the structure of a graph is, and why do we care?
And you said the quiz too. I'm assuming the quizzes are just like our lab
Yeah, it's the read.
activities.
It's the read.
It's just the read. You
Be
should be
able
able
to
to
read
trace
code
through
that can use linked lists, trees, and
it.
graphs. I can guarantee, I can absolutely guarantee, because it's been this way for every semester for the last a lot of semesters, there will be a BFS question. I can
Yes.
100% guarantee that. Whether it's in the interview or whether it's in the quiz, there will be at least one BFS question.
So I hope you understand BFS enough to answer a question on it, and enough to do your your lecture task or
Let
your
me be very clear. This applies to Jesse's class.
yeah
The interview obviously is not for Nazar's class.
yeah. The
Though
interview
you
is not
should
for
know how
Nazar's.
to do these things because you will be
For
tested on
Nazar's
this
class, the
very soon.
read is more for you guys as well. Like we give lab activities based on that read as well. You should be
Okay.
able to go through a
Can you
program and understand what's
explain
going on.
the graph slash BFS code Yes, and you want to see BFS in heap and stack and heap. Got it. Done. Easy.
Very simple.
The TLDR on seeing BFS in the heap and stack is everything's in the heap because it's all like objects that you make, so everything's in the heap. There's basically nothing on the stack. It's just references to stuff in the heap. Like all of its references to stuff on the heap. Right, Leo? I'm not going insane, right?
I mean, from what I know, everything just goes into a queue and then everything gets
Yeah, from the
DQ'd.
queue, there's sets and yeah.
Yeah, it's really nothing that's on the stack.
Okay, can we go over linked lists in general? All right, let's do linked lists. Then we'll do both the graph BFS.
Yep, I'm perfectly okay with that.
Paint. Okay, welcome to Microsoft Paint. Actually, wait, hold up. Let me. The syllabus doesn't state about stack and heap, so I assume we won't be asked about stack and heap on the quiz, right? Does it say anything about knowing the stack and heap here? This is what we will test you on, being able to trace through the execution of programs that use linked list trees and graphs.
By the way, I will say this just because I took this class last semester. Nothing's really changed. If you guys haven't noticed yet, your interview and your lab activities for Jesse's course, I hope you guys know that the read and the write, or no, the read and the, I think it's the read and the write. No, the read and the, it's something like that. The read and the write, they're all basically what they're going to be asking you on interviews and lab activities or lab exams, whatever.
They're actually
Jesse's course
exactly,
is.
and we have very, very specifically stated such things.
Like at this point, you should just, if you see that you have an interview coming up, look at what you need to know based on that, and boom, you got it. You got the interview at that point. At least that's from my experience.
No, you're not allowed to have experiences, Leo.
But I'm not allowed to have experiences, yeah.
Gee, oh, okay.
A
I
little
see.
too big.
Well, because I was working in Photoshop last night, and it's just importing all the stuff that I did last night. So, okay.
Damn, this man Leo's beer's getting crazy. Yeah, the past couple weeks have been really tough for me.
Okay. So, let's talk about linked lists. So each one of these things is a linked list node. Really? Can we select the?
Good job, Windows.
Each one of these is a linked list node. That wasn't Windows. That was Photoshop saying that there's no active layer. Yeah. So each one of these is a linked list node. Each linked list node has two parts to it. It has a value, which holds our value, right? So, for example, hold on. I'm actually just gonna make a layer above everything so I can draw over things. This has a value of 1. This has a value of 2. This has a value of 3. Right? Okay. And then we have this next, and this, what this does is it references a linked list node. So it references whatever the next linked list node is. So, for example, this one would reference next here. This linked list. This would reference this next. And then this one would reference null. So what it means is that we can insert and delete stuff from linked lists pretty easily just by rearranging the next variable. Basically just saying if I wanted to insert something here, right, I would be able to just find the eraser tool, which is the thing I remember where it is. Here it is. Right? I'd be able to erase this. And I could just go like, well, actually, the next is here. And then we go up to here. So it gives you super easy insertion and deletion from linked list. What it's not very good at is iterating through. or getting a specific value from that linked list. You can't just say, I want the third thing in the linked list. You have to traverse 3 times through the linked list to get it. Are they mutable or immutable? Mutable, I believe. Yes, mutable.
I would say they're mutable. Yes.
I would say they're mutable.
It depends on how you make it.
If
But
the
they are mutable.
value, if the actual value here, if you declare that as a val, they would be considered immutable, but
Mm-hmm.
they're almost always considered a var, so they're mutable. So you can change the number in it. These are the same thing that Scala's regular lists are, right? Yeah. On the back
Not,
end, yes.
but not exactly.
Yeah.
Not exactly.
Not yes, but also no.
Yeah.
Is the official answer. You don't need to worry about that. We're not going to ask you if it's the same thing as Scala's regular lists.
Yeah.
Yeah, don't worry too much about that. Just this is a linked list though. This makes sense. Whoever asked for linked lists.
I think some questions could be like, hey, does it have to start from that beginning?
Yeah,
And the answer is no.
No.
It doesn't have to
You can
always
start
start at that
from
beginning.
here. You just can't get any port behind it.
Yeah, you just can't go behind it.
How do we determine what the end of the linked list is? It's always a good one. Which in this case, it's always whenever the next is equal to null. Yeah. Anyone else have any questions on linked lists before we move over to BFS?
Yeah. I like spinning in my chair.
I'm doing the same. Also, I have Twizzlers. Very excited.
I have Bean Boozled.
You have what?
Bean Boozled.
Okay. How can we drop a value? Okay, so let's say I wanted to drop the 2, right? I want to drop this thing. So basically, we'd say to the 1, we'd say, hey, yo, dog, you're next. Remember when it was this number? Right? It's actually just gonna go to here.
Hey, yeah, you're next. Yeah, it's gonna point to this node instead of that one.
Yeah.
Sorry.
So basically, you're never able to access that node in the middle because there's nothing that leads to it. So unless you save that node somewhere, then you can't get to it.
Okay, Twizzlers. Yes, I hate Twizzlers too.
Twizzler slap. For LT5, how do we find the width of the level?
That is an office hours question.
Office hours question, but because I'm here and I'm thinking about it, I think there's something in the game state that says the width of it, but I might be wrong.
Off the top of your head, you probably don't know. So the node we're skipping just stays there, but does nothing. Yep.
Yes.
Yep. Does
Can we have a command
absolutely
in linked list where we can use replace command?
I mean, if you really want to go and make it.
Yeah, if you make something, yeah, you can say, yeah, you can make a replace command.
If you like Twizzlers, we legally cannot.
I think I'm just gonna dox Nutzy really quickly.
Yeah, you're gonna need to. I mean, I don't like Twizzlers either. I don't know why you're eating Twizzlers. It's a bad choice from you, Logan.
Twizzlers slap, man.
No, that's a bad choice from you. You set the width in your game state through testing. There you go. Student answer student. Bad choice.
You seem like a Red Vines kind of guy. Which one of us?
I'm probably Logan.
No, one of our friends is a Red Vines person.
Like, I don't even know what Red Vines is. Now I need to go search it up.
They're shitty Twizzlers.
Are they?
Yeah. No, I'm definitely not a Red Vines person.
Oh, I see them. Oh my gosh.
Red Vines are hipster Twizzlers. Oh my.
Oh, I don't think that's a good. That's a bad analogy.
All right. Let's talk about BFS.
Time to talk about BFS.
No.
And how it appears in the stack and heap, but it really only appears in the heap.
Yeah. So this is BFS. Welcome. Okay, you should all understand this code, and there we go. We're done. Nah, I'm joking.
Look, you gotta be a little bit more intensive than that.
Well, no, I was being a jackass, and yeah.
Not not funny. Not funny.
Okay, so BFS, right? We take in a graph and we take in a starting integer, and we make this magical like explored thing that tells us the with a slight modifications, it gives us the best path to a given node. So we have this explored set, which is going to be stored in the stack. Pretty sure Jesse removed the distance variable. Well, that's possible.
If it's if that's what happened, then
Well, this is the one that I pulled from his GitHub last week.
I can take a look really quickly.
I'm pulling it up.
He did remove the distance variable.
Okay, so apparently removed the distance variable. So I just won't talk about it because I'm way too lazy to. Actually, I can just pull. Hold on. I forgot that's a thing I could do.
Yeah, but you're also gonna get everything else that comes with it. Actually, no, you're not. Okay,
It doesn't
never mind.
matter. Okay.
All right.
So
No more distance variable.
no more distance variable. So we have this explored set, which is a set. Sets basically are lists that are unordered, and you can only have one of a given item in there. So you can only have let's say if I have strings of the letters of the alphabet, you can only have one A in there. You can't have multiple of them. So we can explore. We have this to explore queue, which is a queue of integers, which, as we know, is first in, first out. So the first thing that gets in it is the first thing that's going to get out. And we add the start ID to that queue. And then we go into this while loop that basically says, while we have something to continue to explore, we're going to take that node out of it, explorer's queue. We're going to look at everything in the adjacency list of that node, and we're going to check to see if we've explored it. And if we have explored it, then we're going to do nothing. But if we haven't explored it, we're going to add it to the list to explore, and then we're going to add it to the we're going to add the current node to the list of things that we have explored. And that's it. Is the one with leaps will be on the read and explain of the quiz. If so, could we also review that? Thanks. I assume you
Are you
mean
talking about trees?
trees?
I hope you're talking about trees.
I'd really assume trees. Well, yes, leaves are just the bottom of a tree, but they're also
Nodes with no children.
yeah. No, that's what they are. Okay, so
Oui.
I'm gonna assume you're talking about trees, and yes, we can talk about trees. I need Photoshop again. The only computer science review session that you'll see where we switch between Photoshop and coding IDEs with ease.
We're lucky to have someone who has experience in both.
We talk about bushes too. Only shrubbery. And only with high-low effects. Leo, did you get that or no?
Sorry,
I'm
what
gonna be
you
very
say?
upset if you didn't get that. I said we can only talk about shrubbery with a high-low effect.
No clue. I didn't get that.
God damn it.
Sorry, man.
Okay, so let's talk about trees. So remember how we had a linked list, right? That had it had a value, right? Let's write some stuff. A value and had a next. No, you're not going to be quizzed about bushes. Someone's messing with you. Don't worry about it. God damn it.
Quizzed on bushes.
What do you mean by bushes? No. Okay, so this is a linked list node, right? Let me write that out actually.
So if you guys watch lecture, you would know that there is no bushes.
Okay, so this is a linked list node, right? Trees are fancy linked lists. Okay?
Very fancy.
They are. So instead of having a value and an X, they have a value, they have a left, and they have a right. Okay? It's extremely intense, right?
This node has got its pinky up, guys. It's fancy.
It's a fancy version, okay? Basically, what this means is we can have a tree node, which I'm going to refer to as Tn, which has a left and a right, which can be more tree nodes, which can each have their own tree nodes, which all of these lead to
You guessed it.
null.
I was gonna say more tree nodes, and then
Well, they
they
could lead to more
eventually get
tree
to
nodes.
null.
I just didn't really want to write more tree nodes. So, what trees are really good for is something called a binary search tree, which allows us to order things. So, let's say our first thing is a 5. We can figure out where to insert a 4 based on checking the value of our insertion comparative to the current values. So we can go through and search for different things in there based on a value that we currently have and the value that's in the tree. Can you go over how we would find the number of edges between a node and the starting node using breadth first search?
I'm going to say no.
I'm going to say that's a very specific question,
And I
which
think
makes me think you're doing one of the lecture tests for the.
it's either the lecture task or the lecture questions from Nazareth's class, because they just had a to find the distance between a starting node and another node. So with
Basically,
that,
make counters
yep,
is your answer.
yeah, practically. And is BFS a type of graph? No, BFS is a searching algorithm.
Yep. How do you do Bellman-Ford algorithm? You don't.
Well, we're not going to talk about that. You'll
Leo,
see in
do you
331.
even know what Bellman-Ford is?
I know only because I did my own research on different algorithms for trees. I mean, for graphs. And
Okay.
yeah,
I don't like Bellman-Ford.
I'm
So yeah,
going
you'll learn a
to
ton about the Gale-Shapley algorithm.
I'm going to learn about a lot of algorithms. 331. I
But
can't
definitely
wait.
the Gale-Shapley. BFS
BFS
versus
versus DS
DFS.
or DFS.
Okay. Yeah. Yes. So coding wise, it's just where when we switch what node we're doing. Basically, breadth first search goes over a wide. Hold on, what's the best way to show this? Where's the slides? So if you're in Jesse's class, okay, whatever you're about to see, don't worry about it because Jesse didn't teach us and he's not expecting you to know DFS. Okay,
But this is Nazrin's class.
this is for Nazar's class. I talked about DFS, so we'll talk about DFS really quickly. Basically, breadth first search says, okay, I am on this node, okay? I'm going to explore every node related to this node. So we explore here, then we explore here, then we explore here, then we explore here. And then it'll go, okay, now we're going to explore every node related to this node. And we explore everything directly attached before we move on, okay? The way that DFS works is it goes as deep as it can go immediately. So it'll go UCLA, then it'll go Stanford, then it'll go SRI, then it'll go Utah, then it'll go MIT, then it'll go Lincoln, then it'll go Case, then it'll go Carnegie, then it'll go Harvard, then it'll go BBN, then it'll go Rand, then it'll go, I don't know, SDC, and then it'll stop. And then it'll go to the next thing that it can do, which in this case is UCSB.
Well, yeah, it'll go back to Rand and then I'll go to UCSB.
Yeah. But
and everything else would be. But you should, like, I don't want to say you shouldn't be worried about it because this is material that could be presented on the final for Nazrin's course.
But yeah, it's literally DFS uses a stack,
just
BFS uses a queue.
That's the bigger difference. Just understand that.
We all feeling a little bit better now.
Are things being clearer now? Are the clearest?
Can you explain graphs in general, not by BFS? Sure.
Yep.
This is a graph. Um, this is a graph. They're fancier linked list nodes, right? So how we talked about before, how linked list nodes, right? Um, this doesn't work. Let me
uh,
just do ye old select and delete kind of vibes.
sure. As long as it works.
Okay, so we're gonna copy this. Uh,
Copy and pasting.
I don't even know what copied.
They copy the
Or-
next. Because look, it's pasted on the tree node.
Oh, interesting. Okay.
That's sad.
Okay, whatever. I can just draw a new box. Okay. So this is a little bit different, right? It has a value, and then it has okay. So it's got an adjacency list, which basically says, um, let me move stuff around so that way we can actually. Da, da, da. Okay. So basically, a graph has a value, and then it has an adjacency list. So it has a list of all of the other graph nodes that it is adjacent to. That's all it is. It's a fancy version of a tree, which is already a fancy version of a linked list. That's really it. Yeah. Um, is the code for BFS always the same? It returns unit, but if we alter it based
Just
on what we need to return, yes. See what Trino said. The algorithm is always going to be the same. Whatever you return is based on what your need is, if that makes sense.
I'll just say that as well. Because it's
Yeah,
important.
that's an important thing. Can you say what you said about graph? Just again?
Just repeat exactly what he said.
Sure. So graphs are fancy linked lists and fancy trees. So instead of having a next value or a left and right value to determine what it's connected to, right? So the next says I'm connected to this next node. The left and right says I'm connected to this node left and this node right. The graph node says is I'm connected to all of the nodes that are in this adjacency list. So it has a list of all other graph nodes that it is connected to. And so you can go to another graph node by looking in the adjacency list and seeing if that graph node exists there. They're all fancy versions of the same thing. How does the heap look for a graph? The same way a heap looks for any object. So the heap would be just like you'd have on the stack like node at 732 or something like that, right? And then in 732 you'd have a value, and then you'd have a list that just has references to other places in the heap of other graph nodes.
I hope that answered your question.
I'm pretty sure it did.
I
I
don't
feel like
pretty
it might
sure.
have.
Also, I'm going to touch up on this because I think a lot of students are getting very confused on testing, and I'm going to say, hey, whatever code Jesse and Nazrin provide, please use it, especially if they provide a test case for you in their slides, or if they provide code in their examples repo. Don't use it, not knowing what it does, but use it in the sense of, hey, you don't need to write the code for it. Understand what it does, though. I get too many questions about test cases and how to write a test case still, and what I should test. If there are example test cases, use them to your advantage. That's what I will say. So long as we know these materials, we should be good for this lab. My self-doubt is growing. Yes, I'm going based off experience. Whatever is in that explain and that read, that is exactly what would be asked during interviews, and usually precisely to the point of exactly what is asked during the lab.
Yeah, basically that. You just need to know linked lists, trees, and graphs. That's it. That's all I need to know.
Yep.
Like obviously you need to know like what Scala is and like basic code and all that kind of stuff. Like it's
Yeah.
not gonna suddenly we're not gonna suddenly forget about like a loop or something like that. We're not gonna ask you what a loop is specifically, but like you need to know all the stuff that leads up to this. So like what a value is considered in here. What the an adjacency list, like what data structure is that? Well, it's a list, right?
Sometimes you get asked like, "Hey, what does BFS do?" Uh, if you called, if we called BFS here, what's gonna happen? Stuff like that.
Are linked lists a fancy word for linked lists, or are they different? If so, how are they different? Okay, so linked lists are not a fancy word for lists. They are a different structure because instead of having indexes, lists are or in concurrent pieces of memory. Linked lists can be anywhere in your memory, um, and that's why they have the next and next pointers on them. So linked lists are not a fancy word for list. They are a different data structure. Marble for VIP. I wouldn't be against it, but wait a little bit longer.
Is BTS an application of trees and BFS an application of graphs? So I'm
Yes,
assuming you're talking about BST,
BSTs, but yeah.
binary search trees. So yes, I would say yes. I think binary search trees are a type of tree, but again, like that's just my 250 me talking. To be completely honest.
Okay, I have two things planned for us for a little bit. If we don't have any other questions, aren't BSTs just a way to sort the trees? No, they're a specific. They are a type of tree in which the way you insert is based on sorting.
Right. Yeah.
They
Yeah, that
are
makes a
no
lot of sense.
a binary search tree versus a regular tree are no different. You declare something as a binary search tree by inserting it in a specific way. Yes, I agree. I agree with what I just said. I said it again in my head.
Yeah. A binary search tree, basically, just think of it like this. You have a middle node. Anything that is lower than the value in that root node goes to the left. Anything that's lower than the value in that, anything that's higher than the value in that root node goes to the right. That's a good way to think about it.
Mm-hmm.
Is that almost always the case? No, that is literally always the
That is
case.
literally always the case for binary search trees. To what
There's
Priest
no
said.
ifs, ands, or buts in a binary search tree. The lower values go on the left, and the higher values go on the right.
Okay. To what Priest said, are lists just using linked lists?
No,
Um,
I don't think so. Actually,
no.
depends.
Kind. Don't worry about it. You don't need to worry about the similarities, the differences between lists and linked lists. Just know for right now that linked lists and lists are different types of data structures.
You will get into the differences in 250,
You don't want to get into them here.
and trust me, that is a whole other conversation.
Mhm. So why linked lists? Why not lists? They're another type of
Lists
data structure that are built for using queues and
and
stacks,
stacks.
and then they also build into tree nodes and graph nodes, right? That we talked about. Well, they're slightly different.
Basically linked lists are like the foundation for other data structures.
Yeah. And then for trees, though, that's not true. They're not always following the list. Yeah. So trees don't. Oh, not all trees are binary
Not all
search
trees.
trees, but all
Yeah.
binary search trees are trees.
Yep. So some trees are not binary search trees. But any tree that does follow what I said,
Binary search insertion is a tree.
yeah. Stacking queue. So linked lists are useful because we can implement stacking queue on them. So yes, you can implement stacks and queues. You can implement graphs with them. You can implement trees with them. It's really like the base foundation for other data structures. Honestly, you'll get more into linked lists in 250.
A lot
I
more
think
influence.
I think the first or second assignment, you get a lot more into linked lists. So it's something like that. I didn't do too hot on that assignment, but that was because I was rushing it. That's okay though. What's the point of a stack in a queue? I am glad you asked. All right. I will start with the queue first because I actually really enjoyed the queue and I thought it was really cool the way it worked. So think about it like this. You have a network packet and you are trying to send a packet of data to another computer. If you send all of the packets, your computer will overload, be slow, and completely be shitty, basically. So the queue is in place to say, all right, well, this packet's going to go first, then this packet's going to come, then this packet's going to come, and then this packet's going to come. And it will kind of be like a holdup and a line as to what packets can come in and out. That's one good example. Um, I'm trying to come up with an example of a stack in my off the top of my head.
A stack of cards.
Yeah, that can
A
work
stack
too.
of cards, a stack of plates. In order to get to the thing on the bottom, you need to take everything above it off.
Yeah. So if you were playing like a card game and you had to take from the top deck, you'd probably have some code that is a stack maybe that takes off the top deck. So
Yes.
yes,
Yes,
so for
Blitzkrieg.
now, yes. For now, yes. I will say for now, yes, because I learned about a different type of queue. But I'm not going to talk about that type of queue.
Yes.
But yes,
Well,
that's
well,
the right
that,
idea.
well, okay. So,
It's
yes, it's actually a different type of cube, but for your care, yes, it is.
what if I lift up the desk and what if I lift up the deck and flip it upside down? Well, you
I mean,
just
that's
kind of just
calling dot reverse on it, but you're going against the point of the stack.
yeah.
But
I
then
mean
you need to flip
regard
the card anyway.
yeah, I mean regardless,
It doesn't matter. You're getting too far into the example. The point is,
yeah.
if you have a stack of cards or a stack of plates or somewhere, then you need to get to the bottom plate. You have to take everything on top of it off.
How is stack related to stack memory? Because that has been
It's
confusing
not.
me for my. It's not
For
related at
all you
all.
care about, it's not.
Yeah, it's not. It's not really. It's not at all related. Why not just reverse it though?
Um,
Like, you're getting too far into the example. Like, just kind of think about the implication of what the stack is actually doing. Not saying like, hey, but what if I do this? What if I do this? Will I be asked to explain if I use that analogy?
no.
No. No. You could honestly say like, hey, a queue is like people waiting in line at an airport. And that's also a good one, so
All right. Anyone have any other questions? Because I have something exciting for us to do. I need to do it for science.
I mean you're going to clip it, but it's recorded and there's
Well,
a
I mean, it
I
clips
mean
it so
you
that
could
way he
clip
can.
it, yeah,
It's easier
that's
for him
true.
to grab. I guess I don't know.
True.
Then you don't have to go through the whole thing.
That's true. Or you better not use that analogy.
Oh, you've been using it. That analogy has been used a trillion times. I'm sure every TA has stated it.
Yeah. So Logan, what is the fun and an innovative thing you would like to show us?
Okay. So basically, yesterday, some company decided that it was a good idea to create an official exam to get certified to work in esports. Okay. And there's a practice test. And for science, I want to see what we can get on this practice test.
All right. We can do this practice test together. Let's do this. I am okay. We'll let the chat decide what answer choices we. How long is it, first of all?
It's long, but
It's
we'll go
long.
through as much of it as we can before we get really tired of doing it.
Okay. Very interesting.
By the way, I'm of the opinion that this is bullshit. Um, so I'm kind of trying to prove that like it doesn't matter if you're like a seasoned professional. Yes, exactly, Jack. Basically, it doesn't matter if you're like a seasoned professional in like video game marketing and stuff like that, or if you're just some random kid off the street. You're gonna have the same damn answer because it's all bullshit.
Basically.
BFS only works with data structures graph, right? Yep. BFS is a
Yep.
graph only thing.